All right. Well, appreciate you guys joining us. And I guess it's afternoon where most of us are. I'm in North Carolina. You know, Dave and I ran into each other in Canada, 2 weeks ago. And so glad you could join us from wherever you're sitting today. So let me do something real quick. Apologize. Get the screen up. All right, here we go. All right. Hey guys, Dave, we troubleshot this, but I'm one screen down here on my end. Just one sec. Look at this. Right. There we go. Okay. So what we're really going to talk today about is giving you some tools and tips and tricks to regarding building a better sediment basin. And as Dave mentioned, I am a certified professional in erosion sediment control, certified professional in stormwater quality, also a SISIC, certified professional agronomist, certified crop advisor. I've got a lot of certifications and worked in a lot of different arenas and for different folks. Done this for about 20 years, so I really enjoy getting on calls and really prefer to be in front of a group of like-minded individuals who are trying to learn about their profession and do better. So real quickly, I'll introduce Warren Faircloth. He is the inventor of the Sediment Basin Skimmer. Here he's holding one of his awards that he received from IECA. He's actually received multiple awards from IECA, from Technical Presentation of the Year to, I think this was his Sustained Environmental Contributor Award back in 2007. So Warren's still with us. This is not an obituary picture. Someone mentioned that once, that it looked like that, but no, he is certainly still alive and well and right down the hall from me when I'm in our Hillsborough office. And Warren spent almost 20 years administering the urban stormwater and erosion control program for the county, Orange County, here in North Carolina. That's where Hillsborough, North Carolina, and Chapel Hill, North Carolina is located. The University of Chapel Hill is right over there. So that's Warren, and it was during that time that that he worked there that he had the opportunity to come up with this idea of floating surface tank for dewatering sediment basins and impoundments. So just a real quick overview of what we're going to talk about today. We're going to go over some, real quickly, just some stormwater rules and regulations, particularly the construction general permit, a history of sediment basins and skimmers, some key components for efficient sediment basins. I give you some just kind of tips and tricks on how to select and specify skimmers, and share with you some design tools and resources for doing that as well. And then lastly, we'll briefly touch on post-construction stormwater management and share with you an innovative flow control technology that we've just released. So I always like to share this picture. This is over in Colorado, taken by a colleague of mine, Dean LaManna. This was four years after a wildfire event. And, you know, I think this just really does a good job of setting the stage of why we're here. You know, we look at this and I just ask, you know, which side of the river would you rather be fishing in, swimming in, drinking from? I think is pretty clear. And at the end of the day, water quality affects us all. And sediment is the leading cause of water pollution, and we have laws in the US to protect water quality. Chiefly, that's the construction general permit issued by the EPA, and you know that it requires the erosion sediment controls that the permittees are required to design, install, and maintain effective erosion controls and sediment controls to minimize the discharge of pollutants. And at a minimum, these must be designed, installed, and maintained to control stormwater volume and velocity, control stormwater discharges, including both peak flow rates and total stormwater volume, as well as minimize sediment discharges from the site. And another rule that not everybody is fully aware of, but in particularly, this is for non-numeric effluent limits. So, you know, in the West, in Washington and Oregon, we have numeric effluent limits. So this kind of is not as applicable out there or where you guys are. But surface outlets are required when discharging from basins and impoundments. Basically, permittees are required to utilize outlet structures that withdraw water from the surface. And so to that end, we'll talk a little bit more about the skimmers. But the status quo is really the perforated riser, as seen here. Here's your perforated riser. You have a pipe with a bunch of holes drilled in it, and it's wrapped with a filter fabric, really to try to help reduce sediment entering into the discharge point. The problem is this is not really a great surface outlet because it actually drains from the bottom. It's going to drain here first, and as it fills up, it might get up to the top, but really this thing is going to drain the dirtiest water in the basin first. And you know, the one thing about a filter is if it does its job, it needs to be cleaned. And this is very, very difficult to clean out. I would say they rarely, I'd almost say never, but there might be an off chance that someone actually cleans it, but rarely, if ever, get cleaned. So this is what these perforated risers look like. This is our discharge point here. You see a bunch of rock pushed up around it after we've wrapped it in filter fabric. Same thing down here. Again, very, very hard to clean. You can see the erosion in this basin just coming down here, that sediment deposition. It looks like maybe they have cleaned the stone there, but it's very, very uncommon that they will clean this. And what essentially happens when you don't clean it, it blinds over. And we send the, when the basin fills up, it doesn't drain properly, and we send all that water over the emergency spillway. So it's just like any device that filters, it must be maintained. Actually, I took this picture this morning of my dryer. I had just done a load of towels. So you've got to clean these out when, you know, when this gets filled up, just like I said, just like that perforated riser. If you don't, you know, it's a little more catastrophic, you know, dire consequences here. But essentially, you know, we have to, any device that filters must be maintained to perform as designed. So these filter or these perforated risers are not just a kind of set it and forget it either. They really need to be anchored down. They become quite buoyant. Here, this one has floated up. Here, here's another one. This one floated up, took out the emergency spillway, and sent everything downstream. So you can see the kind of the concerns of using this old perforated riser. Now, in contrast, what we're talking about is using creating sediment basins with a floating surface drain as our outlet structure. Just for clarification, sediment basins are well, they're typically characterized by a permanent outlet structure, as you see over here with this concrete outlet over here. They are also designed for larger drainage areas. Depending on the jurisdiction that you're in, drainage areas are typically capped at 75 to 100 acres, just depending on, like I said, where you're working. So, you know, very large areas of drainage coming down to the single point, capturing that water, as compared to sediment traps. Sediment traps are usually for drainage areas of 5 acres or less, so much smaller drainage areas. And they're also very, they don't have a permanent outlet structure. These are just going to be temporary, and they will typically have just a PVC pipe through an earthen dam. Should point out on this with the sediment basin, these are put in during construction. This will typically be capped after construction, and this will be turned into a post-construction stormwater pond afterwards. So. And again, with the sediment traps, very, very efficient to build these. We build literally thousands of these in North Carolina. Very easy to build, very inexpensive. You can even see this tarp here as the emergency spillway. And there's some baffles in here, and we'll talk a little bit more about baffles and their importance to the proper function of your basin or trap. So this is kind of the history of how we ended up with these sediment basins and traps with floating surface skimmers. This is very typical of sediment traps built back in the 1980s, what Warren will call the Stone Ages. They're undersized, not maintained. You see sediment, you know, blowing outside of the perimeter of our project and going down into the stream. This is right behind that project. You can see an axe down here give you a sense of scale for the amount of sediment that we're losing into that stream. So this was, well, it's not acceptable. It was not uncommon at all. And so, you know, Warren thought, you know, we can do better than this. And so in Orange County, he set about to try to do better. And one of the things he did is started sizing the ponds or basins larger, creating larger areas for impoundment. The idea is that the will come to this area, it'll fill up, and then over time it'll settle down and discharge. As you see here in this background, this is actually after Hurricane Fran that left downtown Raleigh underwater, under about 8 feet of water. However, this basin never filled up completely, and this is back in the this is back in the 90s when they're building these things. Is the void space in this rock allowed that sediment-laden water to just flow straight through this. You can see this debris line right here on the top. This basin should have actually overtopped that rock dam in the back. And so one of the other things Warren had read somewhere that, you know, you should use some baffles in the basin, and he'll tell you this is before the age of the internet, and he, you know, he had just read about these baffles but never seen a picture of them or a drawing, and so they just set about to create some baffles with this silt fence, and it seemed to work a little bit, but again, you assume nothing, and we'll get into how to properly use baffles and basins in upcoming slides. So, like I said, Warren, like I said, this was common, and the sediment, the dirtiest water in the basin was leaving first, and so Warren said, you know, it'd be better if we could discharge the water off the top of the basin instead of the dirtiest water out of the bottom of the basin. And so he convinced one of his contractors to let him build a floating outlet structure that would try to do that. So he installed this on one of his job sites. Waited 2 months for it to rain, but after that first rain event, this thing it did just what it was hoping to do. It floated up, and it created the initial impoundment in the basin, which was necessary for gravity settling of the suspended solids. It skimmed the water right off the top, so the cleanest water in the water column is right there at the top of the surface of the water. So we're skimming off the surface, and when he looked downstream, he saw just a slight dusting compared to those slides that we had seen earlier with all that sediment in the creek down below. So he knew he was on to something here, and so, you know, his idea was to create a device so simple that any contractor could build one. He never had the intention of getting into the business of building skimmers or selling them. He was an inspector. He just wanted his sites to be compliant and his contractors to you know, to install devices that would work. So this is, you know, this is supposed to be just something very, very simple, but he found that you know, contractors didn't really want to build these. They sometimes cut corners, and they didn't work quite as they were designed. It started to discredit the concept. So he found he had to get into the business of building skimmers, at least in a small way, to provide quality skimmers that worked. And he went through a series of about 6 or 7 different designs until he came up with a design that he really liked, or one that could stand the test of time. And these modifications on these skimmers were actually done in as well. They were done as they were being used on construction sites, and to overcome challenges they found on construction. They found they had to change to accommodate this. And so Einstein's credited with saying, make a thing as simple as possible, but no simpler. And that's essentially what we have arrived at with the floating, the current iteration of the Faircloth skimmer. And so I loved his, one of his initial taglines was on the cutting edge of common sense. And when people see this, they're like, my gosh, that is just, it's so simple. And it really is. Just real quickly to show you the anatomy of the skimmer. This is where it attaches to the outlet structure. And just for clarification, there are no pumps, there are no motors. This thing is gravity. It's it flows via gravity flow. So right here is where we attach the whole material handling hose that really acts as the hinge. So as the skimmer floats up and down, it flexes. It also allows you to pull it over to the side of the basin for inspection and maintenance. This is considered the barrel arm. It connects the flex hose to the actual skimmer. As we come up, here's the orifice right in here. This orifice is at a fixed depth, so it does not fluctuate. So you have a constant head pressure, which gives you a nearly constant discharge rate. There is this metal screen to protect, help keep floating debris out. These debris guards on the side, these black pieces of plastic here, keep floating debris from getting in here. And then this C shape here is the float, and right here is the vent. And when you have the vent below the orifice, that's what allows for gravity flow to prevent. Oops, okay, and here we go. This shows showing that orifice right there. Also, this opens, it affixes right up here. The screen affixes with just a simple eye screw, so you don't need any tools on site. If you're out there, if you're inspecting a site, you want to pull it over, open this thing up. You don't need to have any screwdrivers or anything to open it up. Just a simple eye screw opens up, and it's actually on the little wire, so you don't lose it. But this shows the orifice, and each orifice, we make 8 sizes of the skimmer, 8 different sizes, and each one has a plate or a plug that can be cut to reduce the size of this orifice. So we can dial it in specifically for the volume of water that we need to drain over a set period of time. And this was playing at the beginning. This just kind of shows how that screen opens. You can change your orifice plate or plug to restrict the flow, and then how the skimmer floats up as the basin fills, and then floats down as it slowly drains the basin over a prescribed number of days. So as we mentioned, we can use traps, basins, and we'll show some pictures of tanks. But this is a picture. This is actually in Shasta, Colorado, or California, Northern California. If you guys know John McCullough out at his Shasta College, out at his erosion sediment control, he does a BMP field day. So this is from this past April when we're out there. But this is a nice basin showing some porous baffles and our sediment trap here. But again, this is just showing how it attaches to a PVC pipe through an earthen dam. Again, sediment traps are temporary and are most likely going to be filled in at the end of the project. Compared to a sediment basin, which has a permanent outlet structure. This just shows it attached to that permanent outlet structure, stub out from that corrugated metal pipe riser. We also have instructions for how to fabricate an adapter for concrete riser. We do not manufacture these, but we have all the details on our website to provide to a welder, and any competent fabricator should be able to create this for you. We can also use these in tanks. This is a landfill in California, actually in LA County. They had a series of these coming down through a canyon. I think there's 9 of these tanks that they were putting skimmers in, and you know, communication is important on any project, and unfortunately this engineer wasn't very communicative. We asked a lot of questions that were never answered, so he did want to put these skimmers inside this inside these tanks. Fortunately, you see that hole at the back of it is a 20-inch hole, and there's 3 of those in these tanks, and that was the only point of entry, and you can see this skimmer would not fit through that hole. So he flew us out to California to refabricate these on site. So, you know, a little bit of communication goes a long ways to help prevent these types of headaches and extra costs. But so these skimmers can be used in traps, and sediment traps, sediment basins, and in these sediment tanks. So I mentioned earlier, porous baffles are, well, I should say the skimmer is only one part. It's only the outlet structure, how we're discharging from the basin. There's a few other key components that we need to address as we're building these basins. And so baffles were were one that are important. The idea with these solid baffles was really to create a meandering path for the sediment or sediment laden water to follow, hopefully create a longer time of travel to allow more sediment to fall out of the basin. However, what they found, and it kind of looks like it's working here. However, what they found is that with these porous baffles, and in states, I know like Virginia, there's a couple others where they actually use plywood baffles, and even these silt fence baffles, what they do is they keep the velocity of the water up by channelizing flow, and that keeps it suspended, or it keeps the sediment suspended and does not allow for the gravity settling that we're looking for in these stilling basins. So here's some research that was done at NC State. Here's the water flowing straight through the basin. Each one of these is our cells, our baffles, 1, 2, 3, 4. So here's our cell 1, 2, 3, 4. The best reduction that we got was out of the jute fence, which is very similar to core matting, coconut core fiber mat. You can see that reduced the velocity the greatest. Sediment fence or silt fence here is actually keeping the velocity up, and this purple line is actually the tree fence or safety, the orange safety fence that you've seen before. So it did a better job than silt fence, but the jute fence or core fiber is really what we want to use. And here's a picture of it. This is a 700 gram core fiber, but it is trenched into the bottom of the basin. This is a 6-foot roll that's trenched in, usually about 1 foot on the bottom, 6 inches, stapled in with side staples in the bottom to secure it at the base. Then you wrap it up. There's a suspension wire that goes across here. Then we flop the rest of the blanket over, and typically we'll use twist ties to secure that on there. Some research done down at Auburn University. This is from the Southeastern IECA chapter meeting down in Auburn this past April. And Dr. Jamie Schuster, this is where she received her PhD, was down at Auburn. And this was part of her PhD was for research for Iowa DOT. And here we're adding dye to the water as it's coming down through this channel. You can see when it hits this first baffle, you start seeing a swirling effect of that. It starts to slow that velocity of the sediment down, and it starts to spread. So you can see in this next picture, it spreads that sediment load across the full width and breadth of the basin. So we're not shortcutting straight from the inlet to the outlet and leaving dead zones on either side of the basin. We're making a full use of that expensive hole in the ground. And I should mention, about 50% of your sediment deposition will happen in this forebay here, the very first bay is where you'll get most of your settling there. So using these baffles like that also helps with ongoing maintenance, that you can typically just maintain this first bay or forebay and help preserve the life of your basin. Really good research that she did down there, and we'll refer to it a little bit more later in the presentation. So not only do we have 20 years, well, almost 30 years of using these skimmers and sediment basins, we also have, and on construction sites, we have a lot of university trials and research that we've done on these. This is Dr. Albert Jarrett, who published some of the first information on skimmers out of Penn State University. He's down at North Carolina State University here doing a sabbatical. So we're filling up this little basin, and then we have all 8 sizes of our skimmers in there, and we're working on calculating dewatering times for these and flow rates. So one of the questions was asked, well, initially, I guess I can show this slide. So initially, that perforated riser that I showed you, the perforated riser with filter fabric wrapped around it, Dr. Jarrett up at Penn State found that reduces sediment loads, sediment discharges by about 46%, so less than 50%. And so Melanie McCaleb, who's a past president of the Southeastern IECA chapter back in 2007, she got her master's degree, and her thesis is on the effects of design changes on sediment retention basins. And here's a picture of Melanie. I think gives her a lot of credit out here, showing that she's not afraid to get dirty. Here she is doing measurements of sediment in these basins. And so, but what she found is that with a standard 10-year trap, we're getting about 37 to 46%, less than 50% trapping efficiency here with these basins. Now, if you see when we increase it to a 25-year trap, obviously increase the size of our basins, going to give us more settling time. That does reduce the, or increases our trapping efficiency. But when we use a skimmer basin, and this is a basin that's using a series of at least 3 baffles and a skimmer as the floating outlet, we're getting greater than 99% a reduction in TSS, or trapping efficiency of greater than 99%. However, these must be maintained regardless of what anybody tells you. No product is completely maintenance free. So if you, your basins, we usually design them to capture 3,600 cubic feet of water per acre of drainage areas. And we want to clean those out when they get to about 1,800 cubic feet. So about half their, when half their volume is taken up with sediment, we need to get in, do some maintenance, and restore that volume. So this is what that basin design looks like for a 99% capture. One of the first things that we need to do is make sure that our slopes are 2 to 1 or less. Typically, these are the slopes on these basins are 2.5 to 3 to 1. And we would need to get some matting on them very, very quickly, get vegetation established. It was found that early in Melanie's research, she found that over 50% of the sediment entering the basin actually came from the basin itself, from the BMP, from having too steep of side slopes that weren't vegetated. So we want to get these stabilized, vegetated. And you can see this energy dissipator ring. So as water is flowing into the basin, we're taking some of that energy out right there as it and it hits this this rock ring. I'm putting these porous baffles across here to slow that velocity down, spread the sediment load across the entire basin, and then we're discharging from the floating outlet right here, or the skimmer surface drain. As you can see, this water is still pretty turbid. Actually, here's a picture. This is in Tigard, Oregon. They created this basin here. You can kind of see the ring here from that sediment laden water. This is not a real typical application. It's a little undersized to the basin, but their intent was good. There's some things they could have done a little bit better with this, but again, you guys are familiar with the working in the PNW. Late in the season, we don't have a whole lot of light. It hits the rainy season. It's hard to get grass established. So this was the option that they used for stabilizing their slopes here. So a few tips here. We want our minimum length to width ratio to be 2 to 1, up to 6 to 1 length to width ratio. The minimum volume required, this should really say 3,600 cubic feet is what we should design to. But when we get to half of that volume, or 1,800 cubic feet, we need to perform maintenance to restore the original design volume. And then down here, this is just a really nice kind of plan. The city of Charlotte and down in North Carolina, but they put the drainage acres. They put in their storm data here, and then wrote right down here the size. They want a 4-inch skimmer with a 1.5 inch or 1.25 inch orifice. And I look at a lot of plans, so every now and then I'll see some pretty clever ones. You want to put a little pile of rocks for your skimmer to settle on, so it doesn't settle right down into the mud. That will also leave you a bit of a standing pool of water. They find that if you leave a standing pool of water, that will take a lot of the velocity out of the incoming inflow from your basin when water's flowing into it, and it also helps reduce turbidity. But having that little rock pile in there is important. Again, here's our basin with a longer length to width ratio with a series of 3 porous baffles, energy dissipator ring over here. Here's a side view of all that. Again, our energy dissipator, series of 3 baffles, nice little rock pile. And this was really clever. This is really the reason I put this one in here. This, I think, putting a clean out stake where you clearly mark the volume where the basin needs to be when maintenance needs to occur on the basin. That's really I think informative to not only the inspector but also the contractor. I think a lot of contractors would do this if they were aware of it, but these clean out stakes really make it easy for everybody, from the inspector to the designer to the contractor, to know when that basin needs to be cleaned out. So I should point out that the skimmer by itself does not produce clean, clear outflows, particularly when we have clay soils. And so that's the case with this project. This is on the backside of the basin, but we're looking at TSS in the basin of over 3,000, and it's getting down, but it's still not. This is not obviously not acceptable. So we recommend using flocculents. Now, I'm not going to get too deep into flocculents. I know it gets a little more complicated out west, whether you're using chitosan or whether you're using polyacrylamide. I know California has just now started allowing polyacrylamide back in. It's been banned out there since 2009. They're calling it passive treatment. I know in Alaska we use a lot of flocculents up there, but whatever flocculants you use, it should be tested to make sure that the type of soil, it is reactive to the type of soils that are common on your project. It should be site specific or project specific, and there are ways to do jar test, and I can give a whole presentation on flocculants, but we're not going to get into that. But just for informative purposes, flocculants bind suspended sediment by attaching several smaller soil particles together and forming larger aggregates or flocks. Those flocks are now heavier, and they will settle out of suspension, and therefore cleaning the water. So using flocculants along with the skimmer is a great way to make sure that that cleanest water in the water column right there at the top is truly clean water, not just cleaner, but clean water that is acceptable to be discharged. The way that we typically want to deploy flocculants is in a treatment train. It's very important to use them with fibrous matting, whether it's straw, coconut core, or even jute matting. Those are very coarse materials that will really grab those flocks really, really well. With these, what they were doing is they sprinkled the flocculant powder onto this mat, and I think they put some right behind these these logs, straw wattles, to help slow the water down and create time for mixing. So this is down at NC State. These logs are actually impregnated with polyacrylamide, and what they did is they put turbid water, let it flow down through here, and we grabbed samples behind each one of these logs as the water pooled, and as you can see, the water gets progressively cleaner. You need to incorporate flocculants upgradient from the pond. Don't just throw like a flock log into the pond and think it's going to clean up the water. It's not. You need to use, like I said, use the flocculants upgradient, allow time for mixing and activation of the chemistry, allow time for flocculation and deposition. And to do that, as you can see, as the water starts coming down to the pond, this is in that energy dissipator ring that we saw on that first on that pond that we showed. You can see the flocculated soil on the bottom, and it says 34 MTU, but that water looks a little cleaner than that. But anyhow, that would be acceptable in the South. I know we need to get to at least 25 in most of your jurisdictions. So this doesn't look like really clean water, but as a part of it is the reflection coming off of that. But we do have clean water in this basin that we're now able to discharge from. So just a quick reminder what the skimmer does not do. It will not make a hole in the ground in an efficient basin. It won't allow for the reduction in the basin size due to improved efficiency. It does not overcome inefficiency caused by poor basin shape or design, and by itself does not produce clean, clear outflows in clay soils. What it does do is it regulates the filling and the draining of the basin, utilizes the basin's volume and surface area, the full volume and surface area, drains the basin from near the surface where we have the cleanest water, that water column, drains it at a nearly uniform rate. So we're really taking a lot of that velocity out of that storm. Can allow for the varying of the drawdown time by changing the orifice. And all these are going to improve efficiency in our basin. So inspection and maintenance, like I said, everything, there's nothing that's truly maintenance free. And so when we're doing our inspections out on the site, and there's a few things that we should look for. If this is supposed to be a floating surface drain, it should probably be floating. This is a competitive product that was installed and clearly does not pass the float test. You want to look for vandalism. These are like little floating targets for kids to throw rocks at, shoot BB guns at, you know, all kinds of stuff. So you want to look for damage. There's just so much wrong with this picture. I'm sure you guys, we could dissect this all day long. But one of the first things we should do is take as much of this out of sediment production as possible. See, we didn't stabilize these slopes, these baffles, and we're not taken all the way to the side. This thing was just buried in muck. You know, but these are all things that we want to look for when we're doing our inspections. You want to make sure that this one was actually not attached properly to the outlet. It was not a watertight seal, so you can see that even though this is out of the water, not able to drain, it's still draining, but it's draining from the bottom because there's not a proper seal on that flex hose. Clearly, this is not going to float. I think this was an accident. This was by design. An inspector in Ohio sent this to me, and you can see this piece of rebar they bent over to keep this thing from floating up. The contractor said it drained so much better when it didn't float up. So that was, you know, that not really the intent or the spirit of what we're going for here. When we're dealing with ice, this is in North Carolina. We get in some areas we'll get a couple inches of ice. This was not a couple inches of ice is not an issue. Minnesota, MnDOT is now requiring skimmers on their projects. And what you'd want to do in an environment like that, or if you're in Alaska, you want to go ahead and just pull these out at the beginning of the season, or at the end of the season. Before the ice is there, you want to just go ahead and pull these out, because when this thing's frozen completely, you're not going to be discharging water anyhow. Every skimmer comes with a rope. Every one of our skimmers comes with a rope in the box. You just attach it here. And so especially when we're doing like seed and straw in the fall time, or in the fall time, if you have deciduous leaves, you can end up with some of this muck that will end up in here. This one's just not been maintained properly, but if you just give a couple tugs on this line, it should swish most of that free. However, again, that flexible hose on it will allow it to be pulled over to the side of the basin. You can clean that out and just redeploy it. However, if you have, you know, a media, a seed, and water, plants will grow. And I joke around and say, I don't, you know, this is a floating wetland. I'm not sure if you're going to get nutrient removal credits for this or not, but really we've seen pine trees growing out of these that have been abandoned in ponds. So for maintenance, we want to inspect the sediment basin at least weekly or after each significant storm event, whatever is going to trigger your inspection for your jurisdiction. If water remains turbid in the basin, reapply flocculents as specified. Remove and properly dispose of sediment when it accumulates to half the design volume. We want to remove trash and debris from the skimmer, emergency spillway, and pool areas. And then periodically check the embankment, emergency spillway, and outlet for erosion damage, piping, settling, seepage, or slumping along the toe or around the barrel, and obviously repair that immediately. So there are some other skimmer designs out there on the market. This is you can tell this is a homemade one. If you build a house and you're the inspector's coming to do the plumbing inspection, you want to see all this purple glue. That's the way it lets the inspector know that, you know, your pipes have been glued together and they're not going to be leaking in your walls. You do not want to see this on your construction site, because that means someone has built one. They didn't want to spend money to buy one. They thought they could build one cheaper. So with these, you just don't know what you're going to get. There are other manufacturers. Faircloth Skimmer was the original skimmer, but like with any good idea, there will be other folks that will, get in, try to, join you in that space. And so we're not here to disparage any of them, but really we want to discredit these build your own. Here they put a vent here. It's above the it's above the inlet, so it's not going to prevent that siphoning. It's also, this inlet is not, underwater. It's partially submerged. Here, this is not an airtight. You attached it with a couple screws, so this is not airtight. So this barrel is full of air floating on top, is not going to drain properly. So we don't want to see build your own. Of course, we prefer you to use a Faircloth skimmer. Like I said, there are other designs out there, and Georgia Soil and Water Conservation Commission, before they reissued their erosion sediment control permit in 2016, they recognized that there are other skimmers out there on the market, and they went to Texas Research Institute, or TRI, out of Denver Downs in Anderson, South Carolina, and had them test these different skimmers. And this was actually presented at the IECA conference in Portland. This is the very first one that I was able to drive to, as the IECA conference in Portland. But this is actually this one paper of the technical paper of the year award there. And basically, the summary of that 30-page report is right here, that each skimmer product and each product size has a unique performance, including this associated hydraulics, which is affected by the flotation, the inlet, and drain design chosen. The discharge rate, is dependent on the specific product design and can only be determined through product-specific testing. I know that's a mouthful, but I only say that to show, kind of set up the conversation that there's 4 different skimmers that were evaluated. This is the Faircloth skimmer here, and a couple of other designs. You can see that these all use different features and functions, and so it's not surprising that they also have different drainage rates. And so I would just highlight these. So this is right here, we're looking at skimmer flow rates in gallons per minute. These are both 3-inch skimmers. We're not identifying which brand or manufacturer, but this is what they're calling a type 1 skimmer, type 3 skimmer. This is just so they could keep track of who skimmers whose. But look at the flow rates. These are both 3-inch skimmers. When this basin over here, the water depth is completely pretty much full, is about 46.8 inches, so almost 4 feet of depth, which is very common for a sediment basin. This one flows at 53 gallons per minute. This one's at 90 gallons per minute. Come down here is that we get lower in water. We're about 8 inches of water here. This one's flowing at 33 gallons per minute. This one's 66 gallons per minute. So literally, this one's flowing twice as fast as this one. So clearly, that makes sense. These are not, even though they're the same size skimmer, they do not have the same flow rates. And so if you designed with the one with the slower flow rate, installed the skimmer with a faster flow rate, the basin will never fill up. You'll be sending turbid water off site. Conversely, if you designed with the faster flowing one, installed the slower flowing one, you're probably going to be overtopping and sending water over the emergency spillway. So either way, not what we're looking for. They found the same thing on the 6-inch skimmers. Again, just to highlight, 236 gallons per minute versus 457 gallons per minute. And this is just another way to show that data, just showing that these flow rates are dramatically different. And Georgia understood this, and they actually required that you pick a manufacturer that on the plans you must list the manufacturer's name, what manufacturer was used as the basis for design. And if you want to submit an alternative product, that's okay. This is not a proprietary specification. It's just as who was used for these calculations. And so, how we select and specify the skimmer size, it is a performance specification where we take the volume of water, that we're looking to capture, the number of days in which we wanted to dewater it. TRI did create an ASTM standard, this D80-107. For calculating the dewatering times for the different skimmers. Put the name of the skimmer that was used as the basis for design right there on the plans. And if you're going to approve an equal, you want to show proof of that ASTM testing and send it back to the engineer to rerun the dewatering calculations and make sure that the product that you want to use, there may be a different size. It may not, like we just showed, it may not match up with the size of the fair cloth skimmer. So these are some pretty good plans here. I like this one. The skimmer shall be fair manufactured by Faircloth or pre-approved equal. I think that's pretty important if there's any designers on the call to put pre-approved equal on there. We're putting the required storage right here. And again, that manufacturer's name, this one came out of Georgia. But we do have a calculator on our website. It's been used for nearly 30 years now. You just put in the volume of water that you're looking to use. Actually, I can do one better than that. Put in the volume of water that you want to, that we're going to need to capture. Then we're going to, right here, put the number of days that we want to drain, and then it will put in right here the size skimmer that we're going to use with the orifice size. And just to show you kind of how that works. Here we go. So let's say we have, let's say we have 80,000 cubic feet, and we want to drain that in 3 days. It's going to be a 5-inch with a 4.5-inch orifice. Now, our biggest skimmer will drain about 100,000 gallons a day. So if we put in, so if we put in 290 in 3 days, that's 29,290. It's going to tell us we need an 8-inch skimmer with a 7.9-inch orifice. Now, if we put in 310,000, which is more than we can, 310, it's going to give you a notice up here that the maximum flow rate for a single skimmer is exceeded. More than one skimmer may be required. And so, I just show that to show that we do have a calculator there. It uses the orifice equation. And if we need to, click on this. You can use multiple skimmers like they did in this basin in a landfill in California. However, if you get to using too many skimmers in a basin, it just becomes convoluted, and you probably need to look at carving up your drainage areas and making smaller drainage areas, and it's going to be more efficient. This is not really a live basin; it's just a test facility. I'm showing there, but I did mention that we do have an innovative, a new innovation for stormwater management. So post-construction stormwater ponds suffer from a lot of the same issues that sediment basins do, in the fact that you have an expensive hole in the ground that doesn't always work the way that it should. They drain from the bottom, draining the dirtiest water in the basin first. They clog relatively easily, and so it's just again, it's not a real efficient use of that expensive hole in the ground. And so, well, actually, this is from NCDEQ, but we have primary and secondary stormwater control measures and retrofits. This is a great opportunity for a retrofit. I'll show you. This is our new permanent stormwater skimmer, and is made out of marine grade materials. It is a marine grade plastic. The Schedule 80 PVC is UV stabilized. You're looking at about 30 to 40 year life on this guy. We have built-in trash racks here on the bottom and on the top. The orifice is right here, well, right inside here at the top. So again, it has a constant discharge rate on this thing. And we tested it down at Auburn University and to come up with the different flow rates. We hit our peak allowable flow rate here at about 3.5 feet of depth. Instead of having to let the basin fill completely, you know, you're going to hit that. Traditionally, you're going to hit your peak allowable flow rate when the basin is completely full. Here, we don't have to let the basin fill all the way up until we start hitting those high flow rates. Auburn did present this at IECA in the form of a paper last year. Here's the hundreds of thousands of data points that we collected to come up with these flow rates. We do have a sizing calculator to help with design with these guys. And just really kind of how it works, this is a very basic animation, but you have your inflow hydrograph, your outflow hydrograph. This is using a weir orifice. You only hit your peak allowable flow rate when the basin is completely full. And this water right here shows the volume of water stored. Here's your peak flow rate when that basin is completely full. And you have the maximum amount of head pressure over that weir orifice. When we use the stormwater skimmer, it starts flowing much earlier in the rain event and is going to flow longer. And this curve should be flattened out a little bit on the back end, but really for illustration purposes, this is what this looks like. And essentially what we're able to do is eliminate this volume of storage, which will allow you to potentially create stormwater ponds that are 20 to 50% smaller in their footprint than traditionally would be the case. And so we have a lot of, there's a lot of interest from home builders in this regard. As you can imagine, they can get another lot or two in their developments. So this permanent floating stormwater surface drain is a structural BMP, post-construction stormwater management. It allows you to easily convert sediment basins to permanent stormwater ponds. We can maximize land use with potentially smaller ponds by reducing the volume of impoundment required. It's great for retrofitting existing stormwater ponds that don't work properly, that maybe clog easily, may suffer from poor design, or you have more impervious surface that's now contributing to more runoff. It's a great way to add more capacity to an existing pond. Usually when we get to post-construction, we have utilities and pavement and things like that. It's very hard to dig those ponds out and make them bigger. But we're able to do all this because we can achieve the flow rates earlier and longer than traditional basins with bottom drains or orifices. Also with those trash racks, it really, one of the guys here in North Carolina says, I think every pond of mine comes with a soda bottle in it that's going to clog up that bottom orifice. So it really helps reduce operations and maintenance cost as well. So we have lots of resources on our website, everything from design drawings. If you're an engineer or designer, we have the sizing calculator, we have cut sheets, we have drawings in DWG format, installation manuals for practitioners, or lots of information there. We do have a very modern manufacturing and distribution facility at our Eater Mountain plant here in Hillsborough, North Carolina. And we nothing that we use is off the shelf. We buy in all the raw PVC. We have 4 or 5 CNC machines that cut out here. They're cutting out inlets right here. These are the rocker plates. So we just found over the years that we had to build these pieces. You just can't go to Lowe's or Home Depot and buy all the parts that you need to make a skimmer that works properly. So we keep inventory on hand, typically ship the same day. If we get the order by about 1 o'clock, it'll go out the same day. If not, we'll ship next day. But we make one product in 8 different sizes. I guess now we make a new product with the stormwater skimmer, but this is all we do. And so don't let a contractor say that they can't find them. They don't exist. We sell through distribution, and so you can reach out to us if you want to find a distributor near you. We're happy to assist with that. So in times past, this is in olden days, I guess this is inlet protection, but this just doesn't cut it anymore with stormwater inspections and growing environmental awareness from the public. We just can't. We've got to do better. And so utilizing a properly designed sediment basin with a floating surface drain or a fair cloth skimmer as your discharge point is one way to help reach that compliance. And so I think we came in slightly under an hour. So here's my information if anybody wants to reach out to me directly. I believe Dave said this is going to be on the website in a little bit. So you can rewatch it, or you can just reach out to me directly if you have questions, comments, concerns, want to know if you can use these in your jurisdiction. I should have said Clearwater Services down in Oregon, they are familiar with these. Western Washington, the ESC manual for Western Washington does reference using skimmers. So yeah, if there's any questions, I'm happy to answer them now.
Brian, there's one on the chat. Do you find the flex hose gets filled with sediment frequently and requires you to pull it in to maintain it?
The flux hose typically does not, no, because the water that's flowing through there, any sediment that would get in there would just be, it would be flushed out.
Okay, thank you. Also, does Washington State allow for passive treatment? Do you know?
Oh, Dave, you would probably know better than me. There is, so you can use, and I think it's called land. I'm trying to remember. I think it's called land treatment. So you can apply flocculents, but you have to apply them up gradient from the basin. You cannot apply them to the basin directly. You can apply them on the ground, but you have to test the water before it leaves the basin to make sure that all those flocculents have been activated and attached to soil particles and dropped out. And there's some ways you can do that. I mean, one of the easiest ways to do it is you take some soil, take it to the back pipe where this thing is discharging, and sprinkle it into the water and see if it falls out of suspension. It's just the easy. I mean, is one way, or you capture it in a jar and put some flocculants in there and see if that will see if it flocks them. That's one way. There are, I know, with chitosan. Chitosan's just it's a whole nother beast, and you can't use it. It's typically used in closed systems like active treatment. Washington State and Oregon is one of the few places that you're allowed to use it, which is really, we can't use it here in the Southeast because chitosan will actually bind to, my understanding is that it will bind to the gills of aquatic invertebrates like fish and your bivalves and suffocate them. But I would check with a local regulator. Don't take my word for that.
Okay, so and I'd just add, yes, definitely check with your regulators in Washington State, because they've been real adamant about chemicals. They're one of the first probably in the country to allow the use of chemicals in active treatment 20 or 30 years ago. So they're really pretty sticklers on this. So whatever state you're in, check with your regulator. Another question, would the permanent floating skimmer that you showed be able to be used in a temporary sediment basin during construction?
It's going to have higher flow rates than what we would typically see. The thing is a behemoth. It is, I would probably say no. It could be possible, but it would be, I would think not. It is it's just really, really heavy, and an insignificant amount of water is not going to lift it up. So it would probably just, I would imagine it might flow through it. I'm not certain, but I would not. I think you'd want to use the permanent or the temporary one for temporary, the permanent for permanent. And we did just receive data back from Auburn on the, just came in this week. I just got the raw data. I haven't gotten the formal write-up. But we're looking to get a TSS reduction from using the permanent stormwater skimmer, and we received a reduction of greater than 90% TSS, a reduction of greater than 90% of TSS using the permanent stormwater skimmer. So we're pretty excited about that, and I would expect to see more about that in the coming weeks and months.
Cool, thank you. Are PDFs of the presentation available if somebody wants to contact you?
Sure. Yep. And if they have Dropbox, I'll be happy to send them the full PowerPoint too, if they like it.
Okay. Thank you. Do we have any other questions? And if you don't want to put it in chat, you can go ahead and unmute and ask directly.
And if you're not comfortable doing that, my contact information is on the screen. If you want to contact me directly, I'm happy to work with anybody who might have questions.
All right, thank you. Before we close, I just want to remind you to please check out our chapter website, PNW-IECA.org, to check on future events and access to our YouTube, where this will be posted as soon as I get to it. Also, IECA International Conference is in Kansas City next February 2023. So check into that. You can find that on our website. And then for those of you that are in Washington State or near, the international conference in 2024, February, is going to be in Spokane. So information will be made available on that early next year. So if we don't have any more questions, let's go ahead and close up. Thank you so much, Brian. I really appreciate you doing this. A lot of great information. And if I don't talk to you before, I'll probably see you in Kansas City.
You got it. Well, thank you, everyone. Appreciate you tuning in today.